I appreciate this opportunity to share some of the new resources in machine learning for engineers. We've developed these MATLAB curriculum modules, and I'll go over some of these today. Some of the machine learning tutorials specifically designed for engineers within the MATLAB environment. First of all, I'll talk about trends in data and machine learning, and then talk about machine learning for engineers specifically. We'll review some of the MATLAB machine learning modules, the 18 case studies, and 36 learning modules that are freely available, and then also talk a little bit about how artificial intelligence is going to help us be more effective as engineers or increases human intelligence. First of all, a little bit about data. Now, this is the number of zettabytes that are created worldwide 2010 to 2035. You think about a self-driving car, 25 gigabytes per hour, a wind farm, 150,000 points per second, or a jet engine, 51,000 gigabytes per hour. So you have all of these pieces of equipment that are generating data, and you can see that the amount that's transmitted and stored is going to be increasing exponentially. So 1 billion terabytes is a zettabyte. So if you think about a billion laptops in the world, each with a terabyte each, that is 1 zettabyte. And so you can see by 2025, that's 175 zettabytes, 612 in 2030, and projected to be over 2,000 by 2035. And so what we want to do is be able to take this data and make it into actionable information. And so that's some of the motivation for machine learning. How can we use this data more effectively to make decisions and produce value? Now, there's been some advances in computing hardware as well. One of the key metrics they look at is performance per watt. Now, CPUs have a unit of 1 there in terms of calculations per watt that you use. Now, if you think about GPUs, that's 2.9. And then if you look at tensor processing units for inference of neural networks, that's all the way up to 83. So there's specialized hardware that's going to continue to improve our ability to process this data and make predictions or be able to train these neural networks or other types of machine learning models. Here's an overview of the Machine Learning for Engineers course, and there's a QR code there to direct you to the website as well. Now, in here, we have these blocks that cover a particular topic for machine learning. Now you can see all the way over here on the right, you have unsupervised learning, semi-supervised learning, supervised learning, classification, clustering, and regression. But there's so many steps even before getting to that point where you need to be able to work with the data, data engineering, cleansing the data, assessing the data, feature engineering, that even come before you get to what we would call machine learning. So the data engineering and the pipeline of being able to curate all of this data is very important. And I'll share with you some of these modules that we've developed and have translated now into MATLAB to be able to help with each of these blocks, this flow chart, this path along the way. So if you look at, this is File Exchange and then also MATLAB Online. Okay, and if you go to File Exchange, you'll see just File Exchange, Machine Learning for Engineers. It'll bring that up. You can also visit the QR code there. You can also select that Open in MATLAB Online. Now, if you have a MATLAB license, it'll open up all of these modules that you can run as live scripts. So it's very similar to what a Jupyter Notebook is. And it's this interactive compute environment where it runs in the cloud through a web browser. And you can see all of these different cells with the example code to be able to demonstrate these different machine learning modules. Okay, so there's our first one right there. This one, I'll go to some additional examples here. Okay, so we have 18 case studies in this course. There are case studies focused on regression, classification, time series, and computer vision. But if you look at the overall map of machine learning, You have so many others as well: the clustering, unsupervised learning, classification, supervised learning, ensemble methods, reinforcement learning. You have computer vision with convolutional neural networks, and many others in here. And then you also have recurrent neural networks as well for some of the time series or the natural language processing as well. So many different topics that you can explore in machine learning. One of the things with this course is that we're focused mostly on engineering applications. How is machine learning valuable to be able to tackle engineering challenges and engineering problems? So let's look at some of the classification case studies. We have lithium-ion batteries. Be able to predict crystal structure based on the chemical elements that you put into the battery. You also have sonar detection. Be able to detect objects underground, like a pipe or a tunnel or something like that, just by sonar. All right, and then you also have steel plate defects. So in manufacturing environments, you want to be able to determine if there are defects in what you're producing. And so this is an example of being able to detect the defects, the types of defects that are there in steel plates. Okay, and there are QR codes with each of these as well. Okay, moving on, there's regression exercises as well. For each of these, I just plugged in the problem description into GPT-4 to generate an image for me. And so polymer regression, this one, we are taking, this is an industrial gas phase unipole reactor, and there are certain conditions such as how much you inject of the monomer, of the catalyst, and you're trying to be able to maintain the viscosity of the polymer. And so you want to be able to predict the melt flow rate of this polymer based on this industrial reactor data. Now, the labels for this are they take a sample every so often and measure the melt flow rate in the lab. But if you can have an inferential, some type of regression that is able to predict the melt flow rate based on the reactor conditions, then that allows you to have some idea about what's happening to the melt flow rate when you're not taking a lab sample. Also, thermal physical properties. That one is of particular importance also for engineers, where you're trying to predict the temperature dependence, or in this case, it's going to be the viscosity of certain substances based on the chemical formulas and the elements that make those up. So using paracore values. And one of the unique things about this case study is it also uses physics-informed machine learning. So you inject some element of physics-based learning within this, trying to predict thermophysical properties such as viscosity. All right, and then there are some that are classification and regression. Additive manufacturing or 3D printing, be able to predict the strength of different types of materials that you use for 3D printing. And then automotive monitoring. This case study is unique because you collect your own data with an OBD2 connection to an automobile. And what you do is you analyze automobile performance, such as catalyst heat up rate, where you activate the catalyst. There's also some other regressions in there to be able to predict fuel economy versus speed. And so you can do a lot with this data. Many modern automobiles have hundreds or thousands of measurements associated with them. And so you're just tying into a piece of equipment such as an automobile. And I found that students really like this exercise because they're analyzing data not just from an online repository that they have no connection to, but it's their automobile or an automobile of a friend that they have. And so they become invested in the analysis, wanting to analyze their own vehicle. Also, concrete strength. This one is an important one with all of the construction materials that are used by engineers, be able to predict the strength of those. In this case, concrete strength based on a number of factors and features that you can have a high, low strength, be able to do classification, or the compressive strength of that concrete. All right, on to computer vision as well. So in this one, we are using photographs and be able to recognize what is in that photograph and using computer vision methods. So some of those are like texture classification, be able to identify seed versus sand versus fabric. The other one is soil classification, picking out the amount of sandy loam or clay or rock that's in soil. Also road detection for self-driving cars. This is a very important one. Be able to segregate the image and be able to detect the pathway the vehicle should follow. We also have hand tracking as well. So this could be used in safety systems where hands shouldn't be in certain rotating equipment areas. Facial recognition as well, and then bit classification. So different drill bits, and be able to recognize those from with a convolutional neural network. All right, so many of these are classification, but also computer vision as well. Then we get on to time series. Now it's automation with LSTM. It replaces a proportional integral derivative controller or a model predictive controller with an LSTM, long short-term memory model. You could also do that with a transformer as well. In this case, the example that I show here is in Internet of Things. Okay, this is a cybersecurity application where you're trying to determine if the heater is on or off, or somebody else has control of that and is spoofing the value. Okay, and then we also have wind power as well. It gives time series, but then has a regression trying to predict wind power that's coming in the future based on the current conditions, but also what happened previously. Okay, so there are QR codes with each of those as well, and these are interactive examples that have data with time series. All right, so a couple others that I'll share as well. Soil classification, and highlight some of the things with these live scripts and with MATLAB. And the first one with soil classification is going to really show the programmatic and interactive workflows within MATLAB. And then with hand tracking, we're going to use Simulink for data acquisition and image segmentation. And then ARX, it's really a case study that demonstrates the power of using MATLAB with Python. So let's go on to some of the soil classification. It's a live script and notebook environment in MATLAB. It's a programmatic approach to create a deep neural network. It gives a step-by-step description to create the deep neural networks interactively. So let's go through this one. I'll go ahead and just go through this. We're trying to determine gravel, sand, or silt. And we're going to put those into these directories. All right, and we're going to make a classification model of the soils based on these photos. So we're going to create our training and test directory. We're going to download the files that are there. You could take photos of your own soil samples. And then we're going to load the training and test sets. Then we're going to build our convolutional neural network. Okay, each of these cells operates and builds something in a different way. Now we're going to have this, this workflow that we're working through. It shows us our neural network structure and properties. Okay, so it shows these different layers. You can have fully connected layers or these convolutional layers as well. And it shows the training and the accuracy. And then you have the import of the data. You have some training options. And then you go on to the model testing as well. So we're predicting silt, and the true value is silt. Here's predicting gravel, true value gravel, and predicted gravel. Okay, here's one that's misclassified, sand versus gravel. Okay, it's a mixture of the two. but didn't get that one right. We might need to do a percentage of those. Okay, and then how to load the model if you want to deploy it somewhere else. Let's say you want to deploy this on a piece of equipment, such as a horizontal directional drill, and be able to classify soil automatically. And then just some supporting functions as well. Okay, so that shows a little bit of the workflows, and also be able to build these convolutional neural networks in these layers. Let's go on to hand tracking now. This demonstrates Simulink with a model to track hand and face based on color segmentation. Okay, it allows multiple hand recognition techniques and alternatives. So let's just go ahead and go through this one. This is an interesting one, because students are able to use their own webcam and be able to collect their own images for hand tracking. All right, so go ahead and play this one. Now this one also uses Simulink, and we're going to show how you can mix these different types of models. Okay, so here's the Simulink model. I'll go ahead and run this one. And okay, so it'll take just a little bit to run. And here we go. It's going to segment the image. And here you can see, okay, Sean is there, and it's able to segment, okay, his hand and also his face. It also got that picture frame a little bit over there, but it's able to do a fairly good job of extracting face and hand segments. Okay, so let's go on to the next one now. There's also ARX example. This one is MATLAB with Python integration. And on the right, I show programming language popularity over time. Looks like I'm missing an M there in programming. But if we look at MATLAB plus Python, you think about Python as like a very good MATLAB toolbox that you can call. And this is an example of calling the Gecko optimization suite for model predictive control using an ARX model. Now, Gecko is downloaded about 250,000 times per month, and MATLAB allows you to call Python packages and be able to extend the capabilities of MATLAB with these Python routines as well. So if we just look at MATLAB plus Python, one of the things that we're looking at here is, if you extend the capabilities of MATLAB with Python, then it becomes automatically ties into this very large open source package repository where you can call and extend the capabilities of MATLAB. Okay, so here's the ARX example. Now, ARX models are commonly used in industry for model predictive control. Now, you have certain types of models, finite impulse response, you have ARX, state space. So these are all common linear types of models. All right, so it's going to call Python, and here you can see a model predictive control, okay, with ARX, calling the Python package and calling the optimizers that are available there. Okay, so let's go on to the next one. This is additional 36 learning modules. I covered many of the case studies. Now on to these learning modules to help engineers understand the details of these different learning methods in classification, in regression, time series, and computer vision. So here's the first one, logistic regression. Now, if you go to the web page, you'll see GitHub. This is a Python notebook. I just wanted to share with you the similarity between the MATLAB Live Script and the Jupyter notebooks that are there. You can see you can run all of these through Google Colab. You can do something very similar with MATLAB online as well. So here's the number classification using logistic regression, also some blobs here, shows the learning rate and also a confusion matrix. All right, and then if I go over to the MATLAB Live Script, I can either download this and then run it within my MATLAB environment, or I can go to File Exchange Machine Learning for Engineers and select that, and then just open it up in MATLAB Online. And then what I need to do is just select, this one has AdaBoost already, but what I want to do is come down here to logistic regression. And there I have the learning exercise for logistic regression that shows how to train logistic regression from scratch. So you're not just calling a package. You can do that, but it also shows the details of how to program logistic regression without using any package. So it gives some more details about the learning methods. And we're using number classification in this case. Okay, so there's our logistic regression, the algorithm, the learning methods. It shows our confusion matrix, also our learning rates, shows it converging. All right, and then the other thing I want to show is in the AdaBoost. They're missing packages. If you're going to run this locally, you want to install some of these dependencies or packages. So for example, I needed the statistics package, statistics and machine learning toolbox, and it's very easy to add those from MATLAB. So I just wanted to show this, that in each of these modules, it has all of the dependencies. And so if you go into that module, you can install those if you have the license for them, or if you go to MATLAB Online, all of those already exist. Okay, let's take a look at the k-nearest neighbors learning exercise as well. There are case studies that show how to program k-nearest neighbors, doing it from scratch, or also if you used a package to call. Okay, so here's the MATLAB Live Script with k-nearest neighbors, and we're going to load our data and calculate an accuracy. Okay, so it says fit CKNN. Okay, fit the classifier for KNN. Okay, now if you don't have that, you need to make sure you change the directory. Here I'm going to change it to where that data file is stored. So, and then when I come back here again and I will try to load this data, then it will let me proceed without an error. Okay, here's just a case study that's recognizing cats and dogs. And you can do k-nearest neighbors programming. Again, programming these algorithms from scratch that show you what's going on underneath the hood when you're using some of these algorithms. So I found that to be particularly helpful for engineers when they are learning these methods, to have some case studies where you just call the package and it's able to train and test, or you program it from scratch as well. And that gives you more insights into how the algorithm works and some of the hyperparameters that go into making those machine learning algorithms work. Okay, so I want to just shift focus a little bit here. Using AI to enhance human intelligence. And this is a very important topic because as we use some of these packages, we have some of the great generative AI tools that are there. What can we do to enhance education versus destroy education? So we could destroy education if we just let students take shortcuts and bypass learning by using some of these tools. But we can enhance education if we give them a one-on-one tutor experience. And this is something that Salman Khan also related in one of his recent TED Talks, that how do we take it from conventional learning, where we have one teacher for 30 students, and move it more toward one-on-one tutoring, which we know is much more effective. We look at the summative achievement scores with one-on-one tutoring versus conventional learning, we see a huge difference. Now, what can we do with some of the generative AI tools to help with this? Okay, I want to show an example. This is MathWorks. They have an underlying GPT-4 or 3.5 Turbo. In a minute, I said I'll ask you to generate a learning exercise for me on data cleansing with machine learning. First, ask me a series of 3 multiple choice questions to assess my understanding of MATLAB. Wait for me to respond to each question before asking the next question. Okay, at the end, pose a learning exercise based on the level of MATLAB proficiency. All right, so let's see what it'll do. It gives me 3 questions. It didn't do them in order for me, but that's fine. I'll go ahead and answer all 3 of these. What's the command to create a 3x3 identity matrix? Okay, I'll just say that's A. Second question, answer. I'll say that one is, let's see, mean of vector. Okay, that's going to be B. Third question, answer. Okay, 2 matrices horizontally in MATLAB. Okay, I think maybe that's B instead. Okay, so here it's assessed my understanding. And then one of the nice things about this environment is that, with a code example of, that. And one of the nice things is that you can run these and it can execute these functions or these test scripts on the right pane. So as you're working with this and using it as your one-on-one tutor, that you can see the results of your code all within this environment. One of the things that I talk to some of my students about is, if we can have this foundation of remembering and understanding, we get up to more of the applying, creating, evaluating, and analyzing. So we get up to these higher levels of learning and knowledge where we're creating something new. And that reinforces these concepts in a different way. So instead of just remembering what is the function for k nearest neighbors, we can focus our effort on assessing the application and how well it's doing if it's able to answer that business question. And then also as we look at business analytics, you'll see this in industry as well, that with increased synthesis comes increased value as well. So we get up to the highest levels. It's like, what is the best that can happen? Predictive modeling, what will happen? Forecasting is like, what if these trends continue? And statistical analysis, why is this happening? And get past some of the lower level, like standard reports, ad hoc reports, query drill down, or alerts. So we get up to these higher levels of generating business value with increased synthesis. And I'd suggest that generative AI can help us do that more effectively. They gave generative AI to a fraction of companies' employees. They found that they were able to complete the tasks with 40% higher quality and 12% more tasks and 25% faster. And say this was from the Boston Consulting Group. So we can get beyond some of these remembering and understanding into creating, evaluating, and analyzing. Now, here's a couple of years ago, I was on an offshore platform, and we had to install sensors, these fiber optic sensors, on this in this tip tank of a deep water platform. And this deep water platform was at about a mile deep, these tendons connected to the seafloor. And we wanted to be able to monitor the tendon tension from these pontoons down to the seafloor using fiber optic sensors. Now, one of the things that we did coming into this project was be able to do a finite element analysis of this platform, a very detailed engineering calculation that would relate where we're putting the fiber optic sensors on these web frames of the platform to correlate that to the tendons themselves. So we used engineering fundamentals to try to come up with this calculation. Now, one of the things that we saw when we turned it on is that we noticed there were a big discrepancy between those engineering calculations and the actual values. And first of all, we were trying to, where did we go wrong is what we asked ourselves, and found out that we had made some critical assumptions that were not correct about the finite element analysis. And so then we took machine learning methods and did regression with the few remaining load cells that were still there. And we're able to come up with very good models. You can see in the upper right-hand corner the 6 tendons, and the predictions from the fiber optic sensors are in red, and the blue are the load cells. Now this is subject to wave action, tide fluctuations, and the seasonal temperature variation as well. And so we found that we were able to use machine learning to be able to make this regression. Now we had some of the fundamentals from the finite element analysis, but ended up finding that using machine learning methods was able to get us that answer faster and without any of those assumptions in the engineering calculations that prevented us from achieving the accuracy we needed. Okay, so it taught me a lot about, in this experience, thinking about data engineering and how we take those terabytes of data each day and turn them into actionable information with machine learning methods like regression. So I'll just highlight some of the other courses and other learning material here as well. We have data-driven engineering, okay, the DDE, and there's a QR code for that. There's also this current one, the machine learning for engineers, and that one covers the 18 case studies and then 36 learning modules. And then also the other one that we also converted over to MATLAB was the process dynamics and control course. So that is available in Python and MATLAB with live script exercises, just like in the machine learning for engineers course. Okay, I encourage you to check this one out as well. This was the process dynamics and control course, and using generative AI to help with that course as well. Here's the temperature control lab, and gave it a photo and asked, why doesn't the heater get hot? Okay, it recognized that it's missing the power connection. Okay, and so this is an example of helping students with this one-on-one tutor to, they could take a picture of their device and say, why isn't this working? And in this case, it was able to give the correct answer. Okay, there's just a flow chart of the process dynamics and control course. There are 35 learning modules with this one, and that one is also available. We did a webinar on this in the past, but I just wanted to highlight this as another set of learning materials for process dynamics and control. Okay, so with that, I'd like to thank you for your attention. Appreciate this opportunity to share some of these new learning modules for machine learning for engineers.